Today we're going to talk about the key features of a graph. When you graph functions, there are specific properties of those graphs that can help us describe what's going on within our function. And so today we're going to talk about the increasing and decreasing properties of a graph, positive and negative properties, and x and y intercepts, which you've probably discussed before. Starting with increasing and decreasing, we need to understand that we always read a graph moving from left to right, just like you read a book. And as I move from left to right, if my graph is pointing up or has a positive slope, we call that increasing. On the other hand, as we move from left to right, if our graph is headed in a downward motion or has a negative slope, that's decreasing. It is possible for a graph to have both increasing and decreasing properties within that same graph. So before we state where this graph is increasing or where the graph is decreasing, let's review how to write an interval. Intervals represent a group or range of values, and intervals are always written according to their endpoints. If an endpoint is part of our interval, we use a square bracket. If an endpoint is not part of our interval, or happens to be one of the infinities, since that's not an actual number, we write those values, or we use rounded brackets in our intervals. It is possible that intervals can have mixed brackets, where I have one square bracket and one round bracket. Let me show you what that looks like, because hopefully that sounds a little bit familiar. We kind of did the same thing when we graphed inequalities. Remember our open versus closed dots? Well, that's the same situation as a square or a round bracket. For instance, if x is greater than 0, I would graph an open dot at 0 and shade everything to the right, extending all the way to positive infinity. Well, to write that interval, I say my left boundary is 0, and my right boundary or right endpoint is positive infinity. Since 0 is not included in our range of values, I use a round bracket. And same thing kind of goes for positive infinity. Since that's not an actual number, I always use round brackets on infinities. This looks very much like a point, and we're only going to know the difference by taking this in context. Am I talking about a range of values, or am I talking about a specific point on my graph? You have to pay close attention to whether it's an interval or a point. If I wanted to graph or write x is less than 0 as an interval, on a number line, I'd graph an open dot at 0 and shade everything to the left all the way to negative infinity. My interval would say my left boundary is negative infinity and my right boundary is 0. On the infinities, we always use round brackets, and since 0 is not included in my range of values, I use another round bracket. If, on the other hand, I wanted the range of values between -2 and +5 inclusive, inclusive means that the endpoints are included in that range, then my interval would say my left boundary is -2, my right boundary is +5, and both are included, so I use square brackets. Just a side note, if -2 was included and has a solid dot, but 5 had an open dot, so it's not included in our range of values, we would use a square bracket on the -2 and a round bracket on the +5. That's an instance where we would have mixed brackets. So now let's take a look at the section of graph where it's increasing. It's the right half of this graph that's increasing. That's the section of graph that has a positive slope, right? To write its interval, we need to look at the x values only and determine its left boundary and its right boundary. Since this is the half of the graph that's increasing, it starts where x is 0 and goes all the way out to where x is positive infinity. So our interval then goes from 0 to positive infinity. In these cases, where x is 0, that's neither increasing nor decreasing. That's where it switches from decreasing and begins to increase. So we always use round brackets with increasing and decreasing. This graph is decreasing on the left-hand side. Our left boundary, where it starts to decrease, is negative infinity, and our right boundary is 0. So from negative infinity to 0, this graph is decreasing. One more time, keep in mind, always remember that intervals only include x values. So even though this graph is pointing upwards towards positive infinity on the y-axis, it's the x-axis that counts when it comes to our interval writing. Let's take a look at another graph. First question, for what interval or intervals is it increasing? In this case, we have two sections that are increasing. So I have to take both sections into account. The section on the left, if I'm looking at x values only, starts at negative infinity and comes all the way to -4. This right section of graph that's increasing starts where x is 8 and extends all the way out to where x is positive infinity. So I need to include both sections when I write my intervals. To do that, I go ahead and write both intervals using the union sign between them. Now this middle section of graph is the section that's decreasing, and again I have to pay attention to the x values in that section. This starts decreasing where x is -4 and stops decreasing where x is 8. So my interval from -4 to 8, not including my end values. All right, now let's move on to positive and negative. This can get a little bit confusing at times because we've always used positive and negative when talking about slope, and this is something completely different. Functions are positive. The official definition says when the graph lies above 0 on the y-axis. What it actually means is above the x-axis. Functions are negative when the graph lies below 0 on the y-axis, or in other words, when the graph is below the x-axis. Don't let that confuse you. Again, we have to take it in context. For what interval is this function positive? Remember, it's not asking about positive slope, it's asking where the graph is above the x-axis. This graph sits above the x-axis from where x is -2 all the way over to where x is +8. So that's our interval. Again, not including the endpoints, because when you're sitting on the x-axis, it's not above or below. We also have two sections of graph where this function is negative. We have a left section that extends from negative infinity to negative 2, and a right section that starts where x is 8 and goes all the way out to where x is positive infinity. When I write my two intervals, I have to include both, not forgetting to put the union symbol between them. You've talked about intercepts before, so just a quick review. Intercepts are always where the function crosses or touches an axis, and of course the x-intercept is on the x-axis and the y-intercept is on the y-axis. Very quickly, here we have a graph. We have only one y-intercept because the blue line only touches the y-axis at one point, and that point is 0, -6. We have two x-intercepts, however. We have x-intercepts at -4, 0 and at 4, 0. Just a quick side note, sometimes x-intercepts are called zeros. We'll get into that a little bit later, but if it ever asks for zeros, it's asking for x-intercepts. Let's do just some quick practice to make sure you have this down. Here we have a graph. We want to look at where this function is increasing and or decreasing. Take a close look. Where is it increasing and where is it decreasing? Since this graph always has a positive slope, it's never decreasing, but it's increasing forever, right? How far to the left does forever go, and how far to the right does forever go? Well, that would be from negative infinity to positive infinity. Those are our left and right boundaries. So if it's always increasing, we use the interval negative infinity to infinity. Now let's look at the intercepts. We have an x-intercept right at 2, and we have a y-intercept down here at -4. So we say the x-intercept is at 2, 0, and the y-intercept is at 0, -4. Positive, again, in this instance, means above the x-axis. So where does this graph start being positive, and where does it stop being positive? Doesn't it start being positive where x is 2 and extends forevermore? So we say over the interval from 2 to infinity. What's the interval where this function's negative? How far to the left does that extend and how far to the right? Isn't that from negative infinity to 2? Hopefully you got that one. If not, go back and look at the example again. One more quick practice. Here we have an exponential function. Just remember that exponential functions get really close to the asymptote, and the asymptote in this case looks like the x-axis, so it's going to get really close to the x-axis but never actually touch it. So is this function increasing or decreasing, or both? This function is always increasing. It never has a negative slope, and the interval for always increasing is negative infinity to infinity. Our intercepts are a little tricky this time as well. Since this graph never actually touches the x-axis, we don't have an x-intercept. But what's the y-intercept? We could write that there's no x-intercept and the y-intercept is here at 0, 1. Where is this function positive, or over what interval is this function positive? Since positive means above the x-axis, this graph is always above the x-axis. So again, we use the interval from negative infinity to infinity. And is this function ever negative? No, so we can say it's never negative, or we could use the empty set symbol. All right, I've kept you long enough. I wish you a very good day, and I'll see you next time.